Hey guys, it's Amilcar, that guy that walks into your classroom sometimes has a pink binder. I don't know if you know me. Oh well. Well, Miss Taylor asked me to explain exponential growth and decay, and I know she just posted a video about it, but I'd like to go over some stuff. I was kind of confused. Not really, but kind of on some areas, so this is what I came up with. All right, exponentials. So I wrote out a little kind of explanation. A is typically the starting value, B is the change or the percentages sometimes. It could be interpreted as, oh, over this change in time, it's gonna double or triple. Like, let's say every week, this value diminishes by 3 or something like that. And X, it's typically interpreted as time. So that's where you would place time. Oops, let me erase that. All right. A is typically the y-intercept. That's where your starting value would be. Going on. All right, your asymptotes. Oops. Your asymptotes for algebra 1 typically are just going to be 0. So this line right here, that's always going to be 0, and your graph is typically never going to cross. Beyond algebra, beyond algebra 1, usually these graphs will become more complex, and sure, you'll surpass the asymptote at y equals 0. All right, interpreting growth and decay. So when b is greater than 1, you can see that it's growth. From left to right, if it's growing, it's growth. And from left to right, if it's less than 1, it's decay. Let's go ahead and look at some examples. They're little crappy examples I made, but hopefully it'll help you. All right, so since we see that 1 is the starting value, it's the y-intercept. So we could see that the graph intersects at 1. And since the value at B, or at this pink 3, is more than 1, it's 3, we know that the graph is a growth exponential graph. And same thing over here, since the A value is 3, the y-intercept is at 3, and since it's less than 1, it's decay. Alright, so after reviewing this slide on Miss Taylor's last video, I noticed that the B equals 1 plus or minus R might be a little confusing, so I'd like to explain that a little. Okay, so for example, let's say you invest $100 into a bank account with an interest of 15%. Now, without following all right, oops, my bad. The 1 plus or minus, let me fix that, plus or minus R. In this case, R would be 15, correct? Now, without following that, your equation would look something like y equals 100 times 15x. Now, or 0.15x, my bad. Yeah, the point, dang, there you go. So, this is how your graph would look like without adding the 1 plus or minus R. Now, let's say this $100 you put into your bank and your annual rate is 15%, meaning that after 1 year, they're going to add 15% of your original value to your formula. So let's say you plug this in 100 times 0.15 to the power of x into your calculator, let's say by 1. Now 100 times 0.15 to the power of 1. That would be 15. So because we didn't add the 1 to your R, or to your rate of change, or yes, to your rate, the original value diminishes to whatever is inside of the parentheses, or whatever B is. So the B value is what kind of interprets where your starting point, or where you go after your starting point. So we need to add that 1 to your 15%, or to your 0.15, to make it seem that your end value after 1 year would be 115 and not just 15, if that makes sense. Now, I wanted to see if we could answer or do this slide without the graph, and instead of a graph, use an equation. So I made up a pretty approximate equation to the graph in Ms. Taylor's last video, and I'd like to see if we could answer it. So going off of this graph, we could see that in the B value, it's 0.85. So is this a growth or a decay model? So since 0.85 or yeah, so if 0.85 is below 1 or less than 1, we know it's a decay. So let me underline that real quick. It's a decay model. Now, what is the value of the car starting at? Now, we could see that the A value is 32,000. So we could put 32,000 in place of the starting value, or A. And in 4 years, is the value of the car, or what is the value of the car? Now, the value of the car, what you could just do is get your calculator, plug in the equation I made, and go ahead and in place of X, just put 4, or yes, just put 4. And your answer should be, give me a sec, about 1,600, or about 16,704.2. Now, going on, when is the car, or when is a car worth about $8,000? Well, with an exponential equation, there's many different ways you could do it. One way you could do is just plug it into a graph. Now you get your calculator, or you go to Desmos and you go ahead and plug it into the graph. And what you could do is either find a T-chart, make a chart, or just go down the line, find about where $8,000 would be after so many years and mark it down like that. Or you could do algebra and you plug in 8,000 in place of f of x, but that requires things like logs, and I'm not sure if Miss Taylor would like to teach that yet. That's a little more complicated. Not as complicated, but it's easier to just plug it into your calculator since you would have a calculator. I'm guessing. I don't know what your situation is. Hopefully you have a calculator, but I just wanted to explain that. I know I didn't write many things down. It's kind of complicated. I'm doing this on a phone. Yeah. So thanks for listening. And what I'm not sure if you're still listening, but if you are, what my job, or what I'm here to do, is be kind of an assistant to Miss Taylor. So hopefully I could make more videos explaining things that people might have questions about. Now, I was gonna do a Algebra 1 star test review, but since you don't have the star, there is no need for an Algebra 1 star test review anymore. And that changes my job a lot by trying to help Miss Taylor out and make these videos. So thank you for listening.